Hi viewers, welcome to this video. In this video, we are going to be looking at is a likely a 2025 likely UTME physics question. Now, this question is one of the very important and most tricky question in most O-level exams. Now, what does the question state? The question states the distance covered by a moving particle is given as function of time as s equals to 2t square plus 5t in meters, where t is in seconds. Find the velocity of the particles at t equals to 4 seconds. Now they give us option A 21 meter per second, B 52 meter per second, C 30 meter per second, D 15 meter per second. Now, what I want to clear to know is that this question is coming from a topic motion, which part non-uniformly accelerated motion. Now, how do you know that a question in motion is coming from a non-uniformly accelerated motion? Of course, you know a motion is said to be non-uniformly accelerated if its velocity changes with time. If the rate of change of the acceleration isn't constant, right? So now, when in a uniformly accelerated motion, now the questions there is that one of the variables, that is either distance or displacement, velocity or acceleration, will be represented by an equation. Like in this case now, it was distance that was represented by this an equation. So anytime in motion equation you see that a variable is being that one of these variables, distance, velocity, and acceleration, is being represented by a function or an equation, your mind should tell you that that equation is coming from what? A uniformly accelerated motion. Now that you recognize that, now that the equation is coming from a non-uniformly accelerated motion, your mind should tell you that you need the idea of calculus from physics to solve that. Now, why? I will explain. Now, after recognizing that the equation is from a non-uniformly accelerated motion and you need the idea of calculus, ask yourself the equation that was given to you, which of the parameters between distance or displacement, velocity and acceleration is the word equation representing. Now, from the question, now you read the question, you find out that this equation is representing what? Is representing distance. Now the question states the distance covered by a moving particle is given as function of time as this. So x is the distance. Now t is what? Standing for what? Standing for time, right? So they now say in meters. Now having known what the equation is representing, now is representing distance, like in this case now, you will need to know what they are asking you to look for. Now they are asking us to look for what? To look for velocity. Now distance represented by equation to obtain what? To obtain velocity. Now I know some people will be too eager to just substitute the value of t, that is 4, in this equation and then solve. Now when you do that, you are very wrong. Are you together? Now, after recognizing that the equation is coming from what? A non-uniformly accelerated motion, now you know you are going to use the idea of what? Calculus. Now, of course, you know that calculus contains two different topics. Now we have differentiation and we have integration, right? Now, remember that when I have a monomial, a function, let's say n raised to the power n, and I am to differentiate this, now the dy all over the ds is equals to ns raised to power n minus 1. True or false? True. So if I have s raised to the power 2, now the dy ds, or the differentiation or the derivative, will be equals to dy all over what? ds equals to what? 2s raised to the power 2 minus 1, which equals to 2s raised to the power what? 1. Or I can just write it as what? As 2s. All together. Now, what if I have the function s raised to the power of n? Now I want to carry out integration. Please pay attention to this point I want to give to you now. Now to integrate is different from integration. Integration, this is how you integrate. Just remember this shortcut. This is how you differentiate. Now to integrate, when I give you a function n raised to the power s, now the integration will be n raised to the power of s n plus 1 all over n plus what? N plus 1. This is what? Integration. Are you together? Now you should know that differentiation and integration, they are two different processes. They are opposite of each other. Now differentiation is the move in the forward direction. Now that is differentiation. Let me write it. Differentiation is the forward direction. While integration is the backward direction. Are we together? So they are antagonists of what? Antagonists of each other. Now, having know that, now let's come and pay attention to distance or displacement, velocity and acceleration. Now, please permit me to clean everything here. Now, when I clean these things here, you agree with me now that when I have distance or displacement, let me present with you. Now, I have velocity, I have acceleration. Remember that change in distance or displacement is what give us what? Is what give us velocity. Are we together? And change in velocity is what give us what? Acceleration. It therefore means that if there's no change in distance, it therefore means that I can never obtain velocity. If there's no change in velocity, it means I cannot obtain what? Acceleration. Now, in non-uniformly accelerated motion, most times they will give you an equation representing a distance for you to obtain either velocity or acceleration. Now, they will give you a equation representing a velocity for you to obtain either distance or acceleration. Sometimes they will give you an equation representing acceleration for you to obtain either velocity or what? Distance. Are you together? Now, either one that they give to you, just note this simple trick I'm about to give you. Now, if the equation requires you to move forward, now use what? Differentiation. Use differentiation. Are you together? Now, if the equation requires you to move backward, use what? Use integration. Use what? Integration. So, if I give you distance for you to obtain velocity, you will differentiate once. If I give you distance for you to obtain acceleration, you differentiate what? 2 times. Remember, change in displacement gives velocity, then change in velocity now gives what? Acceleration. Now, if I give you an acceleration to obtain what? To obtain velocity, you integrate once. Now, if I give you acceleration to obtain distance, you integrate what? 2 times. Are we together? So that's it. Now, in this question, we are given distance to obtain velocity. Now, the equation that was given to us was what? S equals to 2t squared plus what? 5 what? 5 what? T. So now we want to do the dy dx of this equation to give us velocity. Of course, you know the ds all over the t of this equation will give us what? The velocity. And the velocity will be what? Remember the pattern. When I have s raised by n is equals to ns raised by n minus 1. Are we together? So now, if I should continue with that, I am now going to be having 2 times 2 raised to power t 2 times 2t raised to power 2 minus 1 plus 1. Remember, there's an invisible one here, right? 1 times 5 raised to power t raised to power 1 minus what? 1 minus 1. Now, if we should continue, we have v equals to 2 times 2 is what? 2 times 2 is 4. Right? We have t. 2 minus 1 is what? 1. Plus 1 times 5 is what? 5. Now, 1 minus 1 is what? 0. So let's continue. We have v equals to 4t plus what? Plus 5. So this is the equation representing velocity. So at this junction or at this point, we can now substitute the value of 4 of time, which is 4 seconds, in place of t and so. So when we do that, we are going to have it 4 times 4 plus what? 5. 4 times 4 is what? 4 times 4 is what? 16 plus what? 5, which is what? 21 meter per second. Of course, that should give us what? Option A. Option A should get the word, the correct answer. So that is it. Now I want to alter something, and you do a class work for me and give me your answer in the word in the comment section. Whatever you think will be the answer to this question I'm going to draw, you keep it for me in the comment section. Now, if I change here to be let's say 4. If I change here to be let's say 3. Okay, no, let's change here to be 4 and let's change it to be 2. Are we together? Now I ask you obtain the word let's say obtain the acceleration. Are you together? Obtain the acceleration of the product. Now what do you think? Now obtain the acceleration of the word of the body covered in 4 seconds. Now what do you think will be the answer of this question? So I read it again. The distance covered by a moving particle is given as function of time as this in meters, where t is in seconds. Find the acceleration of the particle at 4 seconds. So that will be your assignment. So drop your answer in the comment section.